We now move on to reliability and validity in measurement. So regardless of the measurement type, all measures must be reliable and valid. Garbage in, garbage out. You only get out information as good as your tools that you're using to measure. So an overview of these two concepts, reliability versus validity. In an experiment, you need to pay attention to many things. Arguably, two of the most important ones are reliability and validity. Your experiment needs to be both reliable and valid in order for it to make sense and provide you with good results. So we define reliability as the extent to which the outcomes are consistent when the experiment is repeated more than once, and validity is the extent to which the instruments that are used in the experiment measure exactly what you want them to measure. So let's revisit the example of distractibility that we have been using in previous parts of this content. So we decided to measure it based in part on eye diversions, which we defined as the number of times a child's eyes leave the task or close for 3 seconds or longer during a 1-hour work period in the absence of a physical disruption in the classroom. The problem is this: do we know that when a child's eyes leave the task, that means that they're distracted? Do we know for sure that we can interpret that eye movement in that way? Or could there be another reason, aside from classroom disruptions, that a child moves their eyes like this? And I would say, yes, this is a problem. Perhaps the child looks away when she or he is thinking. I do that all the time, look kind of up. Or maybe the child experiences eye strain and needs to establish a distant gaze for a time. So I'd say that we do have some potential problems with the validity of distractibility. Do eye diversions measure what they're supposed to measure, distractibility? So let's do some work. Let's look at how we would do this. So part 1 is validity in measurement. So validity in measurement, the extent to which a measurement tool measures what it's supposed to measure. So if we take a look at this image, let's concentrate first on this first one. Is it valid? Does it measure what it's supposed to measure? So if we're shooting for this target right in the center, we can see that our data are missing the mark. We are not measuring what we're supposed to measure. We're not hitting the center of the target. This measure is not valid. We'll revisit this image later. So validity, does it measure what it's supposed to? Our little scale here, if it's supposed to be measuring this person's weight in pounds, unless it's a little junior person, it's consistent, but it sure isn't valid. It's not measuring what it's supposed to measure. So construct validity is what we're working with mostly in psychology. Does it measure the construct it proposes to measure? For example, we remember what a construct is. It's an explanatory variable that's not observable, not directly. And of course, intelligence and motivation are used to explain phenomena in psychology, but neither is observable. And then we have content validity. Does the tool measure the content it's supposed to assess? And when we think of that, we think of, like in this class, those little quizzes that you take. Those are the content of this class, and if that little quiz really measures your understanding of this course's content, then it would be a valid tool. We're going to concentrate on construct validity. And so in order to do that, let's just review a little bit that we use correlations to establish validity. And you'll remember from stats that correlations involve a scatter plot where we plot pairs of points for each individual, and correlations describe this relationship between these two variables. The closer the points are to a line of best fit, a line that would go right down the middle of the points, the stronger the relationship. And we would depict these relationships on a score from 0 to 1 in a positive or negative direction, with scores nearer to 1 or to -1 representing stronger relationships. So in this example, we have height in meters represented on the x-axis, and we have weight in kilograms represented on the y-axis, and we would expect that height and weight would be somewhat correlated. And that's what this seems to show, with it diverging more as people get bigger and taller. So we have three types of construct validation. We have convergent validation. Does the test produce results that correlate positively with related constructs? And so, for example, if we're using our eye diversions as a proxy measure for distractibility, it should correlate positively with other scales that might represent distractibility, like maybe excitability. Then divergent or discriminant validation, does the test produce results that correlate negatively with unrelated constructs? And sorry, this isn't fading in quite right. So let's look at the bullet point under number 2. Our variable eye diversions as a proxy measure for distractibility should correlate negatively with scales like maybe concentration. We would expect that as eye diversions or distractibility goes up, maybe concentration ability goes down. And finally, criterion validation. Does the scale predict a relevant real-life outcome? So distractibility, our variable of interest, should correlate with real-life behaviors, like maybe behavioral demerits or poor grades. We might expect that the more distractible a person is, the more maybe behavioral demerits they're getting in trouble at school, and maybe they're also getting poorer grades. We would expect them not to be perfect, but that there would at least be some sort of a relationship. So another looking at these correlations, if we look at some variables, if two scales are expected to produce similar results, and they do, they have strong convergent validation. And here we have our distractibility variable along with reactiveness, and we can see that as distractibility gets higher, reactiveness gets higher. And here we have the divergent or discriminant validation, a negative correlation. As distractibility gets higher, concentration gets lower. Next, we look at reliability in measurement, and let's go back to our little illustration. So reliability is the consistency of scores produced by a measure, and let's look at this middle illustration. Here we can see that the points are all over the board. You know, a couple of them are close to the target, but most of them are all over the place. In this case, since this measure isn't producing consistent results, we would say that it is not reliable. So there are several ways of thinking about reliability. Here we have our little guy on the scale again, and here we have at least weights that seem to be pounds, but it sure isn't reliable if it predicts 150 one day, 225 the next day, 128 the next day, 176 the next day. This is not a reliable scale. So reliability, the consistency of scores produced by the measure. So internal consistency, it's sort of like, I'll read to you what I have here and then explain it in my words. In a self-report measure, a person responds similarly on similar aspects within the measure, such as producing similar responses to the statement, I enjoy cooking and cooking gives me pleasure. So if we have a number of items measuring one construct, we would expect that one individual, their scores would tend to be on the higher end in all of the items within the scale. And so this is called the internal consistency of a self-report measure. And when you're looking for your measurement tool for your project, you're going to see this internal consistency indicated generally by a test called Chromebox Alpha. And that just tells us how strongly all these items are correlated with each other for each individual. And that indicates internal consistency. Scores greater than 0.8 will say this has internal consistency, it's reliable. Another way of indicating reliability is split half reliability. Each half of a self-report measure produces similar results. So if we divide it in half, we'd expect people's scores on the first half to correlate with their scores on the second half. And this is another way to measure internal consistency. But more commonly, we think of these next two. Test-retest reliability consistency over time. So a person would score similarly on a measure if taken again at a later time. Their scores would not be identical, but if we gave the test to a number of people and then gave it to them again, we would see a correlation across time, and that's called test-retest. And secondly, or well, I should say fourthly, we have inter-rater reliability, and this is how consistently we gather or interpret the results. So two different raters would give similar scores to an observable behavior. So if we're using self-report, inter-rater reliability is perfect because the measure itself just has a score calculated with it. But in observational studies, raters must be trained to observe the same phenomena. So for example, in the strange situation task, raters are trained to observe very specific facial expressions linked to infant emotion. And so here, in that task, which I don't have for you here, I think I talked to you about it in a previous lecture, then we have observers who are observing these children, but they have to rate the level of distress of the infants. And we would expect that different raters would rate them in the same way. And that would serve two purposes. It would prevent bias on the part of just having one observer, and it would also ensure that different people could gather data. So here we have observer 1, observer 2. We want them to practice so that they end up rating things the same way. So to close, let's go back to our little illustration. Our first, with all these points off target, was not valid. Our second, with all these points scattered about everywhere, was not reliable. This third, with the points scattered close together and on target, is both valid and reliable.